Peabody Energy's Metropolitan mine is located within the township of Helensburgh. The waste rock generated from washing the coal, called rejects, is transported by truck through the main street to a surface emplacement facility near Campbelltown. This presents environmental challenges in terms of noise, dust, visual amenity and of course road safety. More broadly, the surface disposal of coal mine rejects requires substantial environmental management by the industry. As part of Peabody Energy's commitment to environmental excellence, the only sustainable solution over the life of the mine was to process the rejects into a paste to pump underground. This video describes the main phases of the study and highlights the key results achieved with significance to Metropolitan and the industry as a whole and transferability to the industry. Since rheology is not an exact science, tests were needed to understand the extent of sizing required to achieve the right paste consistency for Metropolitan. Laboratory studies were conducted by both Tunra Laboratory in Newcastle and DMT in Germany. Both laboratories found that a pumpable paste could be achieved without having to use large and expensive equipment such as ball mills or having to introduce fine material such as fly ash like other mines. Field trials were used to define the operating envelope of the paste in terms of moisture content, particle size distribution and potential pumping distances. A 500-metre long tortuous pumping circuit was established with numerous bends, straight runs and up and down sections to test the mixture to its limits. Some outstanding results were achieved. Firstly, pressure measurements indicating that a pumping distance of over 8 kilometres could be achieved. A 50-metre section of pipe was separated to test how long the pump could be turned off and restarted without segregation of the mixture. Separate restart tests were conducted after 20 minutes, 1 hour, 2 hours, 24 hours, 48 hours and even 9 days. Each time the mixture restarted without any segregation evident. The issue of flowability after discharge onto the ground and its behaviour within cave strata were tested by constructing a dam composed of loose rocks. The material was observed to flow easily over the ground at an angle of less than 5 degrees. This was important for rejects to flow into abandoned workings inaccessible by people. The mixture was observed to flow around the loose rocks, indicating it should adequately penetrate the caved gulf. Achieving an in-place strength of over 100 kilopascals was important to eliminate the safety risk of liquefaction and inrush. The project introduced a chemical called EasyFlow from Cellcrete, Australia, to both aid in pipe lubrication and to act as a binding agent. Leach tests were conducted on the chemical to ensure it was environmentally harmless. The strength of the rejects was measured at regular intervals and reached the required strength within 35 days. The dam was deconstructed after 3 months and examined. The distribution of large and small particles indicated that no segregation of the mixture had occurred. Again, an important design criteria to reduce the potential of pipe blockage and to maximise the distance of flow after discharge from the pipe. Following the successful surface trial, the project moved to pilot underground phase. The same plant used in the surface trial was relocated closer to the washery and a sizer was added. Metropolitan intends to integrate an upgraded rejects plant into the new washery building. Following the thumbs up from Peabody Energy Management, emplacement underground commenced in June 2011, following completion of a surface to seam borehole and commissioning of the pipe range. The initial underground pipe range was over 600 metres long, discharging into abandoned workings. At the end of August, some 12,000 tonnes of rejects had been emplaced, which has already taken some 370 trucks off the road. Underground results have been excellent in terms of reliable system performance, large flow distance of over 200 metres from the pipe discharge point, no segregation of the flow, and emplacement strength over 100 kilopascals. In addition to immediate benefits from removal of trucks through Helensburgh, future benefits are envisaged in relation to surface subsidence. Initially, the rejects will be emplaced behind the long wall via flanking roadways. As the technology is developed, rejects could be used to construct cemented rejects pillars at key locations as the long wall advances to reduce subsidence. Mine personnel also see opportunity in a number of areas such as underground road maintenance, construction of stoppings, and any other application where cement is currently used. Application of the technology in other waste disposal methods, such as tailings dams, where in-place strength is a major issue, should also be investigated. In terms of transferability, Peabody Energy has already hosted other company visits to the facility and hold no proprietary over the technology. Peabody Energy would encourage other mines to embrace this technology towards becoming an industry standard. Peabody Energy is committed to this project to eventually eliminate reject trucks through Helensburgh. Metropolitan Mine acknowledges the assistance provided by the following people and organisations: Dave Reiniger, Selcrete, Australia; Tim Gilroy, UGM, Australia; Thomas Bunn, Tunra Laboratories, Newcastle; DMT Laboratories, Germany. The dedicated staff at Peabody Energy's Metropolitan Mine.